Hello, my name is Professor Adjovan, and this is episode 3 of the Quadratic Series. We're going to be looking at a second method, the box method for multiplying polynomials. If you missed the last video, we talked about the foiling method, which is probably the most used method of my students, but this method is very visual, as you'll see in a little bit, and that might be more preferable to you. So we're going to look at three examples in this video. The three examples are on your screen now. So if you're looking at these and you think that you already know how to do these types of problems, then I would recommend going to the next episode in this series. For everybody else, we're just going to go ahead and jump right into it. So with our first example, we're multiplying the two binomials, x plus 3 and 2x minus 5. And what I've already done is drawn a box. This is called the box method for a reason. We have a box, it kind of looks like a table because it's been segmented, and you want to add enough rows or columns that correspond to the size or how many terms are in each of your two polynomials that you're multiplying. So in this case, I have two binomials, so I made two rows and two columns. What I'm going to do is I'm going to take the first term of the first polynomial and put it for the first row, and I'm going to put the second term for the second polynomial or for the first polynomial and put it in the second row. Bear with me for 1 second. There we go. So I have x and a positive 3, which together would make the x plus 3. I'm going to take the first term of my second polynomial and put it for the first column, 2x, and then I'll put the second term of the second polynomial for the second column. So together they make 2x minus 5. It doesn't matter which you use for rows or columns as long as you keep the same terms together. So if I wanted, I could have this as a box with x and 3 on the top and 2x and negative 5. I cannot have it like this. Okay, so I have to keep the like terms together that create each of the two polynomials, but which goes on top of the box and which goes on the side of the box is entirely up to you. I normally put the first one on the side and the second one on top. So that's what I'll be doing throughout this video. Okay, so now that we have this, we can call on some of our geometry skills. If I look at each of these small boxes as a rectangle, we should know how to find the area of a rectangle of being length times width. So I have the length being x, and I have the width being 2x. So if I want to find the area of this rectangle, I could do 2x times x. We can do that pretty simply, 2x squared. And I want to do the same thing for each of these small rectangles. So 2x times 3 will give me the area of this rectangle. 2x times 3 would be 6x. To find the area of this rectangle, I would do negative 5 times x and get negative 5x. And then to find the area of this small rectangle down here, I would do negative 5 times 3 and get negative 15. Now, to get my final answer, the polynomial that is the product of these two binomials, I need to add up all of the areas of these rectangles because my final answer is going to be the area of this entire box. So I need to put the area of each of these and add them together. So I could write it out like this. I could write out 2x squared minus 5x plus 6x minus 15. And after I do that, I should notice that I have a negative 5x and a positive 6x, so we're not done. We need to simplify. We always simplify our answers, and to simplify we need to combine these two terms. So my final answer would be 2x squared. Negative 5x plus 6x is a single positive x minus 15. All right, let's try another one. This time I have 3x squared minus 1 times 2x minus 5. So I'm going to put the 3x squared minus 1 on the side, and I'll put the 2x minus 5 on top. And we're going to do the same thing. We're going to multiply to find each area of these small rectangles and then combine it all together to get the area of the entire box. So 2x times 3x squared is going to give me 6x cubed. Negative 5 times 3x squared is going to give me negative 15x squared. And 2x times negative 1 is going to give me negative 2x. And negative 1 times negative 5 gives me positive 5. So now if I add these all together, I will have the final answer. I'll have the polynomial, that is the product of these two binomials. I will have the area of this entire box. So if I have a 6x cubed minus a 15x squared minus a 2x plus a 5, I now want to look and see, is there anything I can do to simplify this? Is there any terms that I can combine? Well, x cubed, x squared, x, constant. They're all different terms. They all have a different exponent, so there's no terms that I can combine. There are no like terms, so this would be my final answer. Let's look at a different one where we're not multiplying two binomials. In this example, we're multiplying a binomial and a trinomial. So I have a negative 2x plus 7 as my binomial, negative 2x and a positive 7, and then I have a 3x squared plus 5x minus 1, 3x squared plus 5x minus 1. And if you were to write this trinomial on the side, you would have to have 3 rows and two columns. But you could absolutely do it that way. Okay, so now we're following the same strategy. It's just going to be a little bit more work. We need to multiply 3x squared times negative 2x. Well, that's negative 6x cubed. 5x times negative 2x is negative 10x squared. Negative 1 times negative 2x is positive 2x. 3x squared times 7 is 21x squared. 5x times 7 is 35x. And negative 1 times 7 is negative 7. So before I write these down, like we did in the first example, I'm going to circle any two terms that are like, that need to be combined. So I have a negative 6x cubed, and that is the only x cubed in all of these squares. But I have a negative 10x squared here, and a 21x squared here. So these two boxes can be combined. Likewise, I have a positive 2x and a positive 35x. So these two boxes can be combined. So we can kind of circle them. You can mark them, put a line connecting them, or just do it in your head, knowing that these two are going to get combined as we write them down to maybe save ourselves a step. So I have negative 6x cubed. Let me do this in a different color. And then I have the 21x squared and negative 10x squared that need to be combined. So 21 minus 10, positive 11x squared. And then I have the 35x and 2x that need to be combined. Adding 35 and 2 gives me 37x. And then my final term, negative 7. Alright, so this way of multiplying polynomials by drawing a box, I like it because it's very visual, and I think it helps make sure that you're organized and that you're combining your like terms because you can see them and actually circle them together. Drawing a box, though, it is time consuming, so take that into account when choosing this over the foiling method from the last video, or we're going to be talking about a third method called the stacking method in the next video. So, if you found this video helpful, consider giving it a like and consider subscribing for more math lessons. If you have a question, go ahead and comment it below and I'll do my best to see it and give you a response and help you out. Alright, and we'll see you in the next episode.